Hello and welcome back to the lecture of time series econometrics. In this class, we are going to start from where we left in the last class. That is basically, we spoke about the AR characteristics polynomial, right? So we wrote the form of AR characteristics polynomial equation. Now what we are going to do here is to basically obtain the roots of the AR characteristics polynomial. So to obtain the roots of this AR characteristics polynomial, we'll simply use the quadratic equation form where I will have the roots equal to, say, let me write down the roots equal to minus b, which is theta 1, plus minus b square is theta 1 square, my b square minus 4ac. So here I have a negative sign for a, which means plus 4 theta 2 by 2a, which means minus of 2 theta 2. Now I need to determine the value of these roots, and I will claim that the value of this root, if I take a modulus of this value, it should be above 1. Okay, so that is the claim that I'm making. So how I'll write it is basically mod of the same thing. Basically, I'll write again mod of this theta 1 square plus 4 theta 2 by minus of 2 q2 is going to be greater than 1. And why do I claim that? So we have to assume something here. So I'm assuming a complex unit circle on a complex plane, and here the purpose of taking modulus is basically to see sort of the radius of that circle, if it is within the circle or outside the circle. So simply assume that if this value is outside the circle of that complex plane, so we will not have any imaginary root. So we want a real root. So let me just draw that circle of unit radius. So let us have this coordinates on the complex number plane, and if I say draw a circle, say, of unit radius, so it will be something like this. All right, so what I claim here looks like a good circle, given that I am just drawing with my stylus. So what I claim here, if my roots are lying outside the circle in this zone, so then I will not have any complex root. So which I actually do not want. I do not want to have any complex root. I want only the real roots. So for that, I need to have this condition here satisfied. So for now, we can accept this fact that if the modulus of this value is more than 1, so I will have the roots which are outside the unit circle on the complex plane. Okay, and in the next lecture we are going to see using this property and the property of invertibility what else we can actually derive about the relationship between phi 1 and phi 2. Okay, here I have to write phi 1, right? This is phi 1. Okay, so we'll cover that topic in the next lecture.